everyone. My name is Piotr Ciochoń, but you probably know that already, and I'm an industry liaison officer at Solaris. And my presentation today will consist of three separate but interconnected parts. So first of all, I will tell you a bit about Solaris, who we are, what do we do, what are our capabilities. I suspect that for at least half of the people here, this won't be exactly news, but I hope that for the other half, this might be useful when planning some future research projects or applying for beam time. In the second part of my talk, I will try to touch the subject of industry cooperation, of industrial engagement, sort of building on the previous presentations. And in the end, I will share a few words about the Sylinda project, which is why we are here. And I will have some exciting announcements. So, part one, Solaris. Solaris is the interdisciplinary research center located in Krakow, Poland, which operates the first and only synchrotron light source in Central and Eastern Europe. This is what our building looks like on a nice sunny day, or actually this is what it used to look like, because right now it's a big construction site as we are expanding our experimental hall. But anyway, this is our location. Our ring has a diameter of 100 meters, and with the electron energy of 1.5 giga-electron volts, we are a rather, let's say, small facility. We currently have 5 operational beam lines, with 2 more under construction to be finished next year, hopefully, and 1 beam line, crystallography beam line, which is a bit further away in time. And this is actually one of the main reasons why we are expanding our experimental hall. We also have a Cryomem facility with 2 microscopes, and we offer full service for academic and industrial users. So I will give you a very brief overview of our beam lines. I will not go into too much detail, but you might find it useful for beam time applications. So starting with the lowest energy, we have Siri beam line, or we will have next year, which is an IR beam line with a quite interesting combination of techniques of atomic force microscopy, scanning near-field optical microscopy combined with IR spectroscopy. We have 2 UV soft X-ray beam lines, Uranus and Felix. Their primary techniques are photoelectron spectroscopy and also X-ray absorption spectroscopy in case of Felix beam line. We have 2 soft X-ray beam lines, Pyrrhus and Demeter. There you can use X-ray absorption spectroscopy, magnetic dichroism, as well as photoelectron emission microscopy and STXM, scanning transmission X-ray microscopy. And finally, our hard or medium hard X-ray beam lines, Astra, Pollux, and SOLARIS. Astra is focusing on X-ray absorption in the both EXAFS and XANES range. Pollux will be an interesting multi-modal X-ray imaging beam line with micro CT, micro fluorescence, micro X-ray absorption. And finally, SOLARIS will be our crystallography beam line, focusing on single crystal and powder diffraction. We also have a Cryomem facility, as I mentioned before, and we operate 2 state-of-the-art microscopes, Glacios and Cryos. Both are equipped with grid autoloaders, which allows for semi-automated measurements. Both have advanced bioimaging filters and direct electron detectors. And for those of you who might not be very familiar with the technique, it's rapidly gaining ground in the world of structural biology. The typical pipeline of Cryomem goes from pure protein sample, which we place on microscope grids, freeze in an amorphous ice, which then allows us to image single molecules and then reconstruct back the full 3D structure of proteins. Cryomem is growing very rapidly. A few years ago, it won a Nobel Prize, and the number of published structures is growing exponentially. And if these trends continue, by 2030, we'll have more structures published solved using Cryomem than using X-ray crystallography. We also have a team of great scientists doing Cryomem, so we can offer access to the whole range of cryo-EM-related techniques. So from tomography, which operates on the scales from micrometers to nanometers, for single particle analysis, to microcrystal diffraction, which is really useful if you grow crystals, but they are too small to measure on a traditional beamline. Okay. Enough about Solaris. Let's go to the main part, which concerns conversations with our industrial friends. You have heard already that cooperation with industry is challenging, but it's also fun and can provide a lot of added value. But how to actually talk to industry? So the main point would be that you have to forget about your scientific background for a while. When you have your first customer that you want to invite to a synchrotron facility, the first question that arises is how does the synchrotron work and what makes it unique? So you know the traditional story. You have a storage ring, which is this vacuum tunnel with bending magnets. We speed up electrons to the speed of light and keep them enclosed in the storage ring. And then we utilize the light that's emitted on the bending magnets or on wigglers or undulators. The light then goes to the beamlines, and we can do our fancy experiments. Industry likes seeing large research infrastructure, but this explanation is perhaps a bit too complex for most cases. So it's wrong from this perspective. From an industrial user's point of view, synchrotron is this big magical light bulb that emits very cool X-rays. That's what you need to convey to industry. So why do we need this expensive light bulbs if we can go to a traditional laboratory and do the research at a fraction of the price? Again, the answer here must be simplified. It has many colors, which of course means that it covers frequencies from infrared through optical to X-rays. And it's very bright. So it's tens or hundreds of millions times brighter than the conventional sources. So for industry, this translates into the possibility of doing rapid, precise, high-resolution measurements with low detection limits and high quality of data, however you define this. And you have access to some unique characterization techniques which are impossible to find in traditional laboratories. So once you've convinced your industrial customer that it's worth effort to go to this big expensive light bulb and to do your experiments there, the important thing to remember is that industry, especially small and medium-sized enterprises, don't really have the capabilities or manpower to arrange the experiments and to talk to beamline scientists. That's why it's really important to have a single contact point, which is usually in the form of industry liaison office, which basically takes care of all the interactions between industrial partners and scientists, administration, and all the other practical issues. In case of Solaris, we are formally a part of university, which adds another level of complexity on top of that. But so it's especially important that someone guides the industrial clients through this whole process. When the industrial customer is ready to proceed to measurements, you have to then forget about beamlines, about polarization, about all these things that you find really exciting as beamline scientists, and focus really on what techniques are available and actually on what can the customer get out of them. So we have spectroscopy, which allows you to study the composition of material, bond types, and oxidation states of different elements. You have microscopy that allows you to image your samples, if possible with chemical sensitivity and with the ability to probe molecular interactions. And then you have diffraction, which allows you to study the atomic structures for the more advanced industrial users, and to probe order, disorder, crystal phases, phase transformations. Then if you really want to go deep into details, you can show the names of the techniques, but that's really not the key part here. So the general approach is to get initial contact with your potential customers, and there are many ways to do this. So you can go to external conferences, industrial workshops, either organized at your facility or at other facilities. You have sometimes technological scientists, so scientists who have good working relationships with industrial partners. You can publish industrial articles in the coffee table journals that Professor Holmes was talking about. You can do targeted mailing, both cold and warm mailing, if possible. And you can finally use your personal network or the personal network of other scientists working at the facility. So once you have this initial contact, in general, you need to proceed to dedicated presentation and discussion, which then is usually followed by a feasibility study, by a test experiment, which is aimed at testing whether the technique will actually solve customers' problem. And then hopefully you can acquire your customer. So from my quite limited, but still quite not so limited experience, the following success rates are quite appropriate. So out of all the initial contacts, about 10% of customers will want to discuss their problem in detail. Out of those customers, about 25% will want to go to feasibility study. And once you get them hooked on a feasibility study, which is usually low cost or provided at free, about half of them will become your customers. So these success rates don't look so bad, but if you add them up or actually multiply them, you get about 1% total success rate. So this is for every customer that you have on the beamline, you need to make contact with around 100 potential customers. So this is a numbers game. This is a classical sales funnel, and you can try to either increase the number of your contacts or to increase the success rates at each step. And at Solaris, we have started our program quite recently, and we are trying to improve it every month, every year. We have some first successes. So we are cooperating with Orlen, which is a large oil and gas company, which is actually the fourth largest company in Central and Eastern Europe, with over 25 billion euro revenue and 2 billion euro income. So here we have been able to advance to the feasibility study level with great help from Professor Holmes, who measured some exemplary spectra of the company. And right now we are waiting for the commissioning of the fluorescence spectrometer to continue this route. The other company, or actually the research institute that's working closely with the company, with Grupa Azoty, is actually our recurring customer. We've already had them twice during this year, and this collaboration is really quite active. So working with industry is challenging, as we've heard during today's conversation. As an example of Orlen and our cooperation, these are the samples that we got from them, but we didn't really obtain an explanation of what the samples are or what the company wants to measure inside them. We didn't sign an NDA before, but we got some really vague information which forced us, or actually forced Professor Holmes, to do the X-ray fluorescence and then select a few elements that are most interesting, that we suspect are most interesting for the company. But in the end, we didn't really get much information from the customer what they really want, which makes this challenging. In case of the research institute, they were much easier to talk with because they were researchers. They knew pretty much what they were doing and what they want to achieve, which allows us to actually provide useful results for them, to speciate different oxidation levels of atoms in their catalysts. They even were interested enough to request additional training session to be able to interpret the X-ray absorption spectra themselves. So these are our first successes, and we are developing this field very rapidly. And this brings us to the Sylinda project, which is the third part and the last part of my presentation. By the way, this is an AI-generated image, so this is how the computers imagine the Sylinda project. So I would say it's pretty nice. And Sylinda project is the cooperation between 4 European institutions. We have 2 synchrotrons, ALBA, where we are today, and SOLARIS, as well as 2 German universities, so University of Bonn and Hochschule Niederrhein. We also have a few external third parties involved in the project in one way or another. So we have partners from Thailand, from US, and this is a growing network of industry-oriented synchrotrons, so to say. There are 3 main goals of the Sylinda project. The first one is to enhance cooperation between synchrotron radiation laboratories and industry, and specifically to enhance the capabilities of SOLARIS. Secondly, the second goal is to train young researchers, so you, in science management and industry cooperation, and to establish long-term relationships and create the Sylinda network of cooperating institutions and of people with close working relationships. So there are sets of actions that are undertaken under each of these goals, but I won't bore you with details. We are improving our capabilities, we are establishing cooperation structures, organizing events such as this summer school and the upcoming events, and establishing a technology advisory board with cooperation of third parties. And this brings me to the announcement that I pre-announced before. This is not the end of the Sylinda project activities for you. In fact, we have some follow-up activities planned for this and next year. So you will be invited to study visits to the Department of Research and Transfer at Hochschule Niederrhein and to ALBA Synchrotron. And the partners from Hochschule Niederrhein and from ALBA Synchrotron will be able to visit SOLARIS and to do experiments there. We will be organizing an industrial workshop in late 2023, and there will be a dedicated poster session for early stage researchers focused on industrial applications or on their techniques. And finally, some of you will be invited to participate in the pilot industrial experiments at SOLARIS. So to paraphrase quite a known figure, the best is yet to come. And on this note, I would like to finish and welcome any questions from you.
Thank you, Piotr, for your 3 presentations.
Yes.
Okay, do you have any question related with Piotr's presentation? Maybe the question is who is going to be selected for.
Yeah, exactly. So the recruitment will start soon, right after the summer school.
Okay. And I have a question related with the samples and the clients that you have mentioned. After the measurements, you show a report to the customer, and they were happy with the report, and they get the information they were looking for, or you get some feedback, because I understand that sometimes it's difficult to get the feedback, but you get some feedback on this?
So we gave them partial report because we are still finishing some of the measurements, and they seem to be happy, but they didn't give us very concrete feedback. So they have found something in the data that they like, but they are not really sharing which part of this is exciting for them.
Do you know if they are going to make more measurements, or?
I certainly hope so.
Well,
it's for next year.
Okay, this is wonderful. Yeah.
Yes.
Congratulations. Okay. Any other questions? You want to finish soon, huh? Yeah. So.
It's late.
Okay.
Thank you.
Thank you, Piotr.